The probability of completing a project is equal to the joint probability of completing all its paths within the same amount of time. Oh, which means that even though in PERT CPM we spend a lot of time drawing networks and looking at the individual activities, like this particular problem is pointing out, we really only need information about paths if we're worried about probabilities. Let's take a look. A project network has two paths running through it. So what this is saying, just here at the beginning, is that, okay, perhaps we did do the classic network analysis. We had a starting and an ending node, and there may have been two activities, there may have been 200 activities. We don't really actually need to know. In this problem, it's telling us that by the time we were done with the network, there's these two paths through it. There's only two routes to get from the start to the end in that network. Okay, now the first path has an expected length of 10 days and a variance of 2. Okay, that's going to be important. And the second path has an expected length of 11 days and a variance of 1. What is the probability that this project will be completed in 12 days? All right, so first we practice the theory. The probability that this strange-shaped project with two paths in it, the probability that it will be completed in 12 days is the joint probability that each of its paths will be completed in 12 days. That means that in order to comment on the probability the project will be completed in 12 days, we have to first determine what is the probability that each one of the paths will be completed in 12 days. Luckily, this particular project only has two paths, so that means that we only have these two sub-probabilities to go find or figure out. Now, what this is saying is, for instance, for the first path, it has an expected length, all right, meaning that on average, it's 10 days long, and a variance of 2 days. And we remember that from the central limit theorem, that means that its actual outcome is normally distributed, and we are concerned with, fine, even though on average it takes 10 days, right, how often is it at least no more than 12 days? And the way to do that, again, I think, is just picture it. If it's a normal distribution, the center is 10 and the variance is 2, how much of it, basically, is caught to the left of 12? Because that's the probability that you'd be okay, that you'd get that particular path done in 12 days. So I really only want to know the area, right, of that particular curve that's associated with just that path. We're just talking about path 1. How much of it is to the left of 12? Meaning how much of it is some result that is 12 or less, and we would be done in 12 days. Okay, well, I wish I had a table that just told me the areas of normal curve whose center is 10 and its variance is 2. I could just look this up. I could look up the 12. I don't have a table for a normal curve whose mean is 10 and variance is 2. But in the back of my book, and practically in the back of every business analytics textbook there ever was, I do have a table that tells me the area of the curve that is to the left of a certain number of interest for a normal curve that has a center of 0 and a variance of 1, the standard normal curve. Right, the so-called z-table. Oh, I need a z-table to answer that question about path 1 in 12 days. I need a z-table, but what I need to do first is calculate a z-score. I'm essentially going to take my special curve, this one, and translate it into this one. How do I do that? Oh, I remember the z-score. The z-score is the number that I'm interested in minus the mean of my curve divided by the standard deviation of my curve. Okay, so for path 1 here, that would be the number I'm interested in is 12. My curve, the center is 10, and I do have to remain alert here, the variance is 2. but in the denominator of the z-score is the standard deviation. That is the square root of the variance. I just have to make sure that that's actually what I divide by in the z-score. Now I did that and I get 1.41. Okay, so this thing called a z-score for path 1, I get 1.41. Okay, great. What's that mean about the risk of actually getting done with path 1 within 12 days? Oh, I have to look that up. 1.41. Now I remember with a z-table that the first two digits show me the row, 1.4, and it is the second decimal place that shows me the column. So it's 1.41. See the 0.01 up here? Or what is actually occupying that spot on the table? 0.9207. 0.9207. What's that mean? Well, it's actually illustrated at the top of the table. It means that if you cut the curve right there, the number we were interested in, that much of the curve is to the left. Oh, that's the probability. 0.9207. That's the probability of getting done with path 1 within that amount of time. Oh, all right, but that's just path 1. We're still trying to track down the probability of being completed with the project. We need to now know, well, what is, if this is path 1 and there's like essentially a 92% chance you'll be done in 12 days, fine. What is the answer then for path 2? I need some scratch work for path 2. I say, all right, well, path 2, I need to do the z-score again, basically. I need to do the z-score again because path 2, look, there's different numbers. It's essentially, it's a different normal curve. Oh, okay. The z-score is, the number I'm interested in is still 12. That's what I'm evaluating. Minus, and I have to be careful, the second path has an expected length of 11 days. So that 11 goes in the numerator, and a variance of 1. So actually the square root of 1 is 1. That's also the standard deviation. Oh, so I get a z-score of 1. 1 divided by 1, 1 even for path 2. Not a problem. Can look that up on the table. 1 even is right there on the table. Oh, and it says 0.8413. 0.8413. What this means is for this problem, the problem concerning 12 days, the first path, that's the chance that you'll be done in 12 days, 0.9207. The second path, this is the chance, 0.8413. We want to know the joint probability, the probability that both of them would happen. You create joint probabilities by multiplying the probabilities times each other. Oh, all right, so to actually answer this question, we say 0.9207 times, found it here, 0.8413. I did that and I got 0.7746. 0.7746. That is the chance of getting the project done in 12 days. So that's the answer. 0.9207 times 0.8413, right? The two individual probabilities equals 0.7746. That's the answer to that particular question. Basically, there's about a 77% chance that you'll be done with that whole project inside of 12 days. Now, we can speak of the risk associated with a project in terms of what's the probability that you'll be done in a certain amount of time. We can also speak of the risk of a project in terms of what's the probability it's going to be more than a certain amount of time. If you look at the next question, you'll notice it's the same project. A project network has two paths running through it. The first path has, it's the same two paths, an expected length of 10 and a variance of 2. The second, an expected length of 11 and variance of 1. It's this situation here. What is the probability of the project? Now wait a minute, the question is slightly different. What is the probability that this project will require more than 14 days to complete? All right, now This problem is different in that the number that we're interested in is different. This time around, it's not 12, it's 14. Okay, that's one key difference. The other difference is what it asked, more than 14 versus be completed within 14. But first off, let's just look at the 14. Because with the 14, to answer this question, it starts out the same as last time. We just need to gauge first the risk of, or the probability of, getting done with each one of the paths within 14 days. That's actually how I recommend doing this problem, is first, let's figure out what's the probability that we would get done within 14 days. All right, so let's just repeat those steps that we did for the problem concerning 12 days. We would say path 1, I need a z-score, right? 14 is now the number that I'm interested in, minus, now it's path 1, back to path 1, 10. Divided by the standard deviation in path 1 is the square root of 2. All right, I get here 2.83. Okay, that's path 1. That's the z-score. I look the z-score up over here, 2.83. 2.83, 2.8, 2.8, 2.8, 2.83, oh, 0.9977, 0.9977. 0.9977. I'm just going to jot that down so I don't forget it, 0.9977. But what is that? I have to be careful that I remember this. That is the probability that you will get done in 14 days. All right, but that was from the table. Now, repeat the process for the next path. Path 2. Okay, z-score 14 is still the number we're interested in. Path 2 had an expected length, or a mean, of 11 days, divided by the square root of 1. Okay, so now this turns out to be 3 divided by 1, or 3 even. Okay, same step, take that number to the z-table. 3 even is all the way down here at the bottom left-hand corner. 0.9987, 0.9987, 0.9987. Okay, that is the probability of getting done with path 2 within 14 days. Now, next step I recommend is let's determine what is the probability of getting done with the project within 14 days. Oh, because that's an easy next step. Here are the individual probabilities. Probability of completing, and now I'm being careful to label project within 14 days. Simple multiplication, 0.9977 times 0.9987. All right, I did that, 0.9977 times 0.9987, 0.9964. 9964. Oh, all right, so we have revealed that it's pretty certain that you'll get done with this project within 14 days, because 0.9964 is 99.64%, nearly 100%. Oh, but we'd better not walk away from this problem, because it does matter. Way back in the original question, it asked for what is the probability this project will take more than 14 days. I was following the same steps as last time, right? It's very convenient, but what that results in is the probability that you'll be done within 14 days. It's asking the opposite, which is super easy to find at this point, right? More than 14 days. It's not going to be a very big probability. It's the opposite. It'll be 1 minus 0.9964, or what is that, like 0.0036? Basically 0.004 if you want to round, or it's less than 1/2 of 1%. The probability this project will take more than 14 days is less than 1/2 of 1%. But that is the answer to the question that was asked in the case of this particular problem.